Suppose that f of x is a function such that the derivative and the second derivative are continuous on the interval from 2 to 5. We don't know what f of x is, but that's okay. This information is enough for us to answer this question if we know that the function at 2 and the function at 5 have the values of 6 and 7, respectively. The derivative at 2 and the derivative at 5 have the values of 4 and 5, respectively. That's enough for us to be able to answer the question of how to evaluate the integral from 2 to 5 of the function x times f double prime. The fact that it's a product should lead us to think that the best approach to start this would be integration by parts. And so with that said, then we're going to choose u and dv. Now we don't really have the hierarchy here because we don't even know what f is, what type of function f double prime is. But the way it's kind of set up though, with x being in there, we would like to choose u to be x, because otherwise if we choose f double prime to be u, then we take the derivative, we get f triple prime. We're not getting anywhere. See, the goal is to get somewhere, have something that we can have results for. We don't have any information on f triple prime. So with that said, then we're going to choose u and dv. So u is going to be x for sure. dv is going to be the double prime, f double prime of it. What are we going to do? We're going to differentiate u and we're going to integrate dv, just like with all of them. Now, the derivative of u gives us du, and the integral of dv gives us v. So what's the derivative of x? Just dx, 1 times dx. What is the integral of the f double prime? Using the fundamental theorem of calculus, what we should get out is just f prime. It's the function who has f double prime as its derivative. That's how we do the antiderivative. Okay, great. Now we have to put some pieces of the puzzle together, right? We have uv minus the integral of v du. Okay, great. So it'll be x times f prime minus the integral of f prime dx. Now let's deal with f prime dx. The integral of that, fundamental theorem of calculus again, is just f of x. What function has f prime as its derivative? The answer is f. So on the next slide then, we can look at evaluating this. I've treated the integral so far like it was an indefinite integral, but it's not. It's a definite integral. What I like to do is get the full antiderivative first before I then go back and worry about the bounds, the limits of integration. On the next slide, let's do that. So we have our antiderivative. Our job would be to plug in the bounds, upper limit minus lower limit evaluation. So we plug a 5 in and we plug a 2 in, replacing the x. 5 times f prime of 5 minus f of 5. 2 times f prime of 2 minus f of 2. And we have all the information we need from the given points. The fact that f prime of 5 is a 5. F of 5, that's a 7. F prime of 2, 4. F of 2 is 6. Plug these guys in and we're done with discussion. 25 take away 7, that's your 18. 8 take away 6, that's your 2. 18 take away 2, final answer, 16. Okay? We needed for the function to be continuous so we could take the antiderivative continuous on the whole interval. So there we have it. Okay, great.